Question number 14, a stationary smoke particle is hit by fast-moving nitrogen molecule, okay? Which row describe the motion of the smoke particle and what? Nitrogen molecule after the collision. The smoke particle, do they remain stationary? Of course not. It moves, okay? And the nitrogen, what? Molecule, what? It rebounced. So the answer is what? Is A. Number 15. A night storage heater contains a large blocks of what material that is heated electrically during the night. During the day, the block cools down, release thermal energy into the room. Which thermal capacity, okay, and which night, okay, time temperature increase will cause the most energy of, okay, to stored in the blocks, okay? Now the thermal capacity to be stored hugely, that means it's supposed to be large. Whenever the object has larger thermal capacity, that means it will absorb more energy, okay? And the nighttime temperature increase, okay, it's supposed also to be what? Large. So the answer is what? Is A. Number 16. 100 grams of water at 25 degrees Celsius is poured into what? An insulated cup. 50 grams of ice at 0 degrees Celsius is added to the water. So we have 100 grams of water and we have 50 grams of ice. Okay, we mix them together. Okay, the water is there until the temperature of the water has fallen to how much? 0 degrees Celsius. 18 grams of ice remains unmelted. So how much? The mass of the ice melted is that's what we want, okay, because this gain energy from what? From the water, which lose energy as the temperature decreases from 25 to how much? To 0, while ice still at 0 degrees Celsius only melted, okay, and it's not all the 50 grams melted, it's only 32 grams of it melt. The specific heat capacity of water is 4.2 joule per kilogram degrees Celsius. Which value does the experiment give the specific latent heat of fusion of ice? So again, the energy lost by the water is equal to the energy gained by whom? By the ice. Okay, so the energy lost here, there's change in temperature, so mc delta T equal what energy gained by the ice, which is m multiplied by F. So here I'm talking about water, and here I'm talking about what? Ice. I'm talking about ice. So if I want to continue here, what do I have? The mass of the water, it's what? 100 grams multiplied by its specific heat capacity, which is 4.2, multiplied by the change of its temperature from 25 to 0, 25 minus 0, which is 25, equal the mass of the ice melted, which is 50 minus 18, which is 32, 50 minus 18. All of this multiplied by L. So L, it will be all of this divided by 32, and the answer will be how much? Will be 330 joule per gram, which is B. Good? Is it clear? Okay. Number 17. In which does thermal conduction not correct? In which does thermal conduction not occur? Sorry, not occur. A gas, a liquid, a solid, a vacuum. Thermal conduction doesn't occur at all. In which? Exactly. In vacuum, there's no conduction. In gas and liquid and solid, the molecules in touch, okay? So they transfer energy by conduction. It doesn't matter how much they do transfer energy, but they transfer energy. In vacuum, there is no transfer energy by conduction. Number 18. A metal surface of a kettle is hot, okay? What happens to the cold air outside the kettle when it comes into contact with the hot kettle? Into contact, that means, and we are talking about air molecules, which they are cold, okay? They gain this energy from the kettle surface, and they move faster and farther. So the more air becomes less dense, the density of the air decreases. And as the density of the air decreases, it rises. Okay? So the density of the air decreases, the density of the air decreases, the density of air increases, and it what falls? No, it rises. So the answer is what? Yes, thank you, Mariam. Thank you, Muhammad. It's B. Okay. 19. Some hot water is sealed inside a metal can. The can is in a vacuum in outer space. The hot water slowly cools down. Okay, slowly cools down. How does the thermal energy escape into space? By conduction, then convection, by conduction, then radiation, by evaporation, then convection, by evaporation, then what? Radiation. What do you think? Which one is the answer? Exactly. By conduction, then what? Radiation. So we have radiation here, not evaporation actually. Okay, because it's sealed. They say it's sealed inside a metal can. So the answer is what? B. Yes, thank you, Muhammad. Thank you, Saif. Yes. Correct. Excellent. Number 20, about waves here. When water waves pass through a gap, they diffract. The diagram shows wavefront approaching a narrow gap. In which diagram will the diffraction be least? Least diffraction. Yes. Least diffraction. Are you sure? Are you sure, Muhammad? Think again. Yes, the least okay, let's do the opposite. The greatest diffraction happens when the wavelength, okay, is what? Bigger than what? Than the gap. The opposite happens. When the wavelength is small and the gap is big, that means the diffraction will be what? Least. So the answer is what? C. Okay? Thank you, Sif. Yes, when the wavelength is wider than the, when the gap is wider than the wavelength, okay, that means it will be least diffraction and vice versa. Number 21. An object is placed 30 centimeters in front of a plane mirror. This is a plane mirror. And there's an object here, okay? And the distance between the object and the mirror is 30 centimeters. Which statement describes the image of the object? Now, we know that there will be formed an image here, okay, which is also 30 centimeters to the mirror. So the distance from here to here 30 and the distance from here to here 30. Okay, what they ask here? The image is same size and 30 centimeters from the object? No. Same size, yes, but 60 centimeters from the object, from the mirror 30 centimeters. The image is smaller, no. The image is smaller, no. So the correct answer is what? Thank you, Saif and Hamad is B. Yes, 21. The correct answer is B. Number 22. A small object O is placed near a converging lens. Okay, this is O, place converging lens. The lens form an image I. You can see that the image I is behind the object. Which statement is correct? The image I is diminished. The image I is inverted. The image I is real. The object O is close to the lens than the principal focus. Wow, what do you think? Yes, in this situation, because you can see that we are not talking about the rays do not meet, so we are talking about the extension of the rays. So we're talking about virtual image, and the only case for virtual image that the image is magnifying, this lens is magnifying glass. It will be larger, not diminished. It will be erect, not inverted. It will be virtual image, not real. And this happens in the sixth case when the object O is closer than the principal focus. So the principal focus is somewhere here, right? Maybe somewhere here. Okay, so yes, the answer is what? Is D. Thank you. Number 23. An eclipse of the sun happens when the moon comes between the earth and the sun. Which statement is correct? The eclipse of the sun is what happens when the moon comes between the earth and the sun. Okay, which statement is correct? I think that we did this question before. Infrared radiation from the sun disappear before visible light and ultraviolet. Ultraviolet radiation disappear before visible light disappear before infrared and ultraviolet I think, oh, yes, we did it before. Yes. Okay, and the answer is what? Is D. So you can see they keep repeating the same questions, not only the same ideas. So number 23, the answer is D. All the rays, all the radiation is blocked. Okay, disappear at this moment, at the same moment. Number 24. A pulse of sound is produced, okay, at the bottom, okay, of a boat. The sound travels through the water and is reflected from a shoal of fish. We have shoal of fish here. The sound reached the boat again after how long? 1.2 seconds. So it goes and reflects. It's an echo. The speed of sound in water is 1,500 meters per second. How far, okay, below the bottom of the seaboat is the shoal of fish? So we know that distance equal speed times time. But in this situation, since they cover this distance twice as it goes and as it reflects, so we will divide by 2. So it will be 1,500 multiplied by 1.2 divided by 2. And by using calculator, the answer is, yes, the answer is 900B. Thank you. Next question. 25. What is the approximate value of the speed of sound, okay, in air at normal what temperature? It's an easy question. Speed of sound in air is approximately 300 what? 40 meters per second. Okay? 3 times 10 to the power of 8 speed of light in air. I don't know these values for what. Okay, it's the same answer. No, it's not. Yeah, it is the same value. It's not, no, similar value. No, it's not the same thing. Okay? Yes. Fine. 26. Question number 26. Why is soft iron used in the core of electromagnet? A. Soft iron easily magnetize, okay, easily become a permanent magnet. No, this is not correct. Okay, soft iron is a good electrical conductor. What about this information? No, it's not. Soft iron is a poor thermal conductor. It's not used for this question. Soft iron loses, okay, magnetism when the current, okay, of the coil is switched off. Yes, this is an electromagnet. Okay, so the answer is D.